Question 6 is asking us to use the mean value theorem on this function. Just to remind you, the mean value theorem goes like this: f of b minus f of a over b minus a, which is just the slope, at some point has to equal the instantaneous rate of change f prime of c. Okay, so the question we're trying to figure out is, what is c? Okay, so in this problem, I need to figure out f of 1 minus f of negative 1 all over 1 minus negative 1. Okay, f of 1, if you look at it, is 2. F of negative 1, if you look at it, is 0. So I'm going to get 2 over, and then on the bottom will be 2, so that's 1. F prime, so 1 equals f prime, the derivative of this is just 3x squared. Okay, so if you solve for x, you should get that x is equal to plus or minus square root of 1/3, okay, which are both in the interval, so there are two values that satisfy. Question number 7, suppose a curve is defined by the parametric equation. Find the equation of the line tangent. So here's x. What I'm going to need to find is I'm going to need to find dx dt, which is going to be 4t. I'm going to need to find dy dt, which is going to be just 4, and I need to go dy dt over dx dt. That's going to give me my dy dx. So dy dx is just going to be dy dt 4 over dx dt 4t. I'm specifically looking at this when t equals 1. So t equal 1, dy dt, or dy dx, or the slope, is going to equal 1. So the only one that works really without any work is A, so you don't have to test the other ones. Question number 8 asks you to use partial fraction decomposition. I think there's an error on this problem, so we're actually going to skip it. Question number 9, which of the following are true of this function? Its domain is all real numbers. Obviously not true, because you can see there's a vertical asymptote at x equal to 1. So you can't actually have x equal to 1. Next thing, it has a y-intercept at 0, 0. Well, sure enough, if you plug in 0 in for f, you get 0 over negative 1, which is 0. So 0, 0, that works. Okay, so anything with a choice 1 I can eliminate. And it really comes down to, is it 2 only or 2 and 3? It has two relative extrema. To figure that out, I'm going to have to apply the first derivative test. So I'm going to take the first derivative of this function, f prime of x. Notice the quotient rule is going to apply here. Quotient rule says low d high. So I'm going to go x minus 1. D high is 6x minus high d low, which is 3x squared. And then the derivative of the bottom is 1. Square the bottom, x minus 1 squared. Off you go. Okay, simplifying this, let's see, I got a 6x minus 3x squared. So I'm left with a 3x squared minus 6x all over x minus 1 squared. If I want to make my sign chart, it looks like my critical numbers. If I focus just on the top, okay, and I pull out a 3x, that leaves me with an x minus 2. Okay, so my critical numbers looks like there's one at 0, one at 2, and also don't forget the asymptote at 1. So let's make a sign chart. This is f prime. So I got, again, 0, 2, and don't forget the asymptote at 1. Okay, so 0, asymptote at 1, so that's not going to be a critical number. And then I have one at 2. I'm going to make the sign chart by plugging in the numbers. If you notice, the only thing that really matters is this guy, because the bottom is always going to be positive. So if I plug in a number to the left of 0, a huge negative number, this is negative, so overall it's going to be positive. If I plug in a number like a half, this is positive, this is negative, so it's going to be negative. So it went up and down, and then it hits an asymptote. If I plug in a number between 1 and 2, like 3 halves, this becomes positive, this becomes negative, so overall negative. And if I plug in a huge number like 100, positive, positive, so it becomes positive. So you can see clearly that it does have two relative extrema, so the correct answer needs to be C.